All right, so today we're going to be doing our lesson 3.3. We're going to be finding real zeros. So in order to find the real zeros, we're going to have to factor today, which is why we reviewed factoring on our previous lesson. So for prior knowledge, you're supposed to factor the polynomial. So if you notice, this is a binomial. I have two terms. So in order to factor binomials, you have basically two steps. First, check for a GCF, and then our second thing is to check for dots, our difference of two squares. I do not have a GCF in this example, but I do have a difference of two squares. I have a subtraction symbol, and I have an x squared, and 16 is also a perfect square. So I have two squares and a subtraction in between them. So then I can take those and split into two binomials by taking the square root of each one. So square root of x squared would give me x in the first blank. And then the square root of 16 would give us our 4. And then don't forget, you need one of them to be a subtraction, and the other one has to be an addition. So anytime we have a difference of two squares, we need to split it into the two binomials. For prior knowledge, we also reviewed how to simplify these. So to simplify, we're looking for our perfect squares, which are 1, 4, 9, 16, 25, 36, 49, and so forth. So these are our perfect squares, like 1 squared, 2 squared, 3 squared, 4 squared, and so forth. And so in order to simplify, I'm trying to break up my 50 into two more roots. I need to see if I can simplify it by looking for factors that are perfect squares. So if I look at my list of numbers over here that are smaller than 50, I have all of these numbers that are smaller than 50. I'm checking which of those goes into 50. Well, I can see 25 is a perfect square, and that's 25 goes into 50. So 25 is a factor of 50. And I know 25 times 2 would give me 50. And then I need to split that. So the 25 is the same thing as a 5 squared. So when I take the square root will cancel out the square. So it just becomes a 5 square root of 2. And then 2 is not a perfect square, and nothing on the list will go into 2. So that's your final answer. So likewise, we do the root 24. The numbers that are smaller than 24 are 1, 4, 9, and 16. 16 does not go into 24, 9 does not, but I do know that 4 does. 4 goes into 24. So this is going to be the square root of 4 times the square root of 6, because 4 times 6 gives us 24. And then the square root of 4 is 2. That just becomes 2 times the square root of 6. And 6 is cannot be simplified, because the only number smaller than 6 on the list here is 4. 4 does not go into 6, so that is my final answer. For our last example here, we have the root 18. So same thing, look for the numbers smaller than 18. I have 16, 9, 4, and 1. The only one that goes into 18 is 9. So I can split that into the square root of 9 times the square root of 2. And then the square root of 9 becomes 3. And then bring down the root 2. And that's our final answer. And so for the examples today, we are going to have to be able to simplify, which is why we were reviewing these. So for concept for today, we are learning about the fundamental theorem of algebra. And it states that for every polynomial equation of degree greater than 0 has at least one root in the set of complex numbers. So then the degree of a polynomial function determines the number of complex zeros, rational, irrational, and imaginary or non-real. And then irrational zeros always occur in conjugate pairs. So for example, any square roots come in pairs. I have a negative root and a positive root. And so what this is saying, the degree, this is talking about like the exponent or the power, the highest x power, will determine the number of zeros that you have in your polynomial function. So like, for example, if this is a x cubed, this tells me that I'm going to have 3 zeros. If I had an x to the 4th power, that tells me I have 4 zeros. Okay? And then the second part of this is saying that the irrational zeros occur in conjugate pairs. So for example, if I have x squared equals 2, so to solve for x, I would need to take the square root of each side. The square root cancels out the squared, and they need to come in pairs. So I need one that's positive, one that's negative. So then this would give me x is a negative root 2 and a positive root 2. They always come in pairs. And it makes more sense sometimes if you think about like the square root of 4. There are two numbers that can give you the square root of 4. So I can have a negative 2, because negative 2 squared is going to give me positive 4. And I can also have 2 squared, positive 2 squared. That's also going to give me 4. So that's why the square root of 4 has two roots. It's either positive 2 and a negative root 2. Both of those can give me a positive 4. That's why they come in pairs, okay? So for our first example, we are asked to find all real zeros and identify each zero as rational, irrational, or non-real. For math 3, we're not going to focus on the non-real. The non-real are the imaginary zeros, meaning like the square roots of negative, like for example, square root of negative 4. That's going to be imaginary because I can't take the square root of a negative. So for math 3, we're not going to focus on imaginary zeros. We're only going to focus on real zeros, which are rational and irrational. So for the degree here, that's x to the 4th. That tells me that at the end, I should have a total of 4 zeros, okay? And so in order to find the zeros, I need to factor. And then in order to factor, I need to see if it's a trinomial or binomial. This is a trinomial, so I'm going to do blank plus blank and blank times blank. I'm figuring out what two numbers add up to our b value. So my b value here is negative 18. And they have to multiply to a times c. So my a value is 1, and my c value is 32. So 1 times 32 is 32. So I'm thinking of factors of 32 that will give me a negative 18 when I add them. So because 32 is positive, I'm either both positive or both negative. So my factors are negative 1 and negative 32. I can have negative 2 times negative 16 and negative 4 times negative 8. So which of those can give me a negative 18? Well, I can see negative 2 and a negative 16. When I add those together, that will give me negative 18. So in order to factor, I can use my shortcut. I don't have to use our area model. We're going to go straight to two binomials. I'm going to take the first term right there, the x to the 4th, and I'm going to split it in half in the first blank. So x to the 4th cut in half is an x squared. And then in my second blank, I'm going to take these two numbers, the negative 2 and a negative 16. And then in order to find the zeros, I need to make the equation equal to 0. So to find the zeros, I'm trying to figure out when would this equation equal 0, okay? And then I need to find or check to see if I have a difference of 2 squares. Because I have squares, I need to check for a difference of 2 squares. This one's a difference, but 2 is not a perfect square. This one's a difference, and 16 is a perfect square. So then I can split that further. This will become x squared minus 2. And then this, I need to split it into x plus 4, x minus 4, and make that equal to 0. So in order to find the zeros, I need to make each part or each factor and make it equal to 0. So I have this x squared minus 2. It's a binomial, so I'm going to make those equal to 0 and solve for x. So in order to solve for x, we're going to do the inverse here. We're going to add 2 to each side. That'll give us x squared is equal to 2. And then to solve for x, to get x by itself, I need to take the square root. The square root will cancel out the squared. And again, every time I take the square root, I need one that's positive and one that's negative. So my answer for this part is going to be x is equal to negative root 2 and a positive root 2. And I need to do the same thing for the other two pieces. So my next one, I got the x plus 4. I do x plus 4 equals 0. Solve for x by doing the inverse, subtract 4. That'll give us x is equal to negative 4. And then that leaves us with the last one. My last one here is x minus 4. Make that equal to 0. Do the inverse by adding 4. And that'll give us x is equal to positive 4. So for my part A, that was finding all the real zeros. So remember, I'm supposed to have 4 zeros. So I can see 1, 2, 3, and 4 zeros. So now I have all my zeros. The next thing I need to do is identify each one as rational or irrational. So the irrational zeros are the square roots, and the rational is basically everything else. So for my final answer, I need to say that negative 4 and positive 4 are both rational zeros. And then my negative root 2 and the positive root 2, those are called irrational. And that's my final answer. Okay. So let's look now at the next example. Oh, I forgot to mention that for the x squared minus 16, you could have done it on, like let's say you didn't realize that this was a difference of 2 squares. So I'm going to do it over here on the side. I'm going to put or. Let's say that x squared minus 16, you didn't realize that that was dots. You can still solve that by making that equal to 0. Let me do this on the side over here. And then you're going to add a 16 to each side. And that'll give us x squared is equal to positive 16. And then take the square root of each side with a plus and a minus. So that'll give me x is equal to. You need to recognize that 16 is a perfect square. The square root of 16 is 4. So my two answers are negative 4 and positive 4 because they need to come in pairs. Okay. So even if you didn't realize that they had a difference of 2 squares here and you didn't split them into 2 binomials, you can still do it this way and you'll still get your 2 zeros. Same answer. Okay. All right, so this next example, again, no GCF, so I can just go straight to factoring, and then at the end, I'm supposed to have a total of 4 zeros. So I'm checking blank plus blank and blank times blank. So my B value is negative 10, and my C, 8 times C is 16. So factors of 16, I know they have to both be negative because my 10 is negative. So I have negative 1 and negative 16, negative 2 and negative 8, or negative 4 and negative 4. So my two values that will give me a negative 10 would be negative 2 and negative 8. Okay, so then I'm going to take my two binomials. The first term splits in half, so that's x squared. And then I'm going to put these two values, the negative 2 and the negative 8, in the second blank. And then make those equal to 0 to find the 0. So then to find the 0, make each piece equal to 0. So I'm going to take x squared minus 2 equals 0. use algebra to solve for x, so add 2. And then take the square root of each side, and you got a plus and a minus. So x is equal to, again, negative root 2 and a positive root 2. Then do the same thing with the next piece. I got x squared minus 8 equals 0. We're going to add 8 to each side. That gives us x squared is equal to 8. Take the square root of each side, and I need a plus and a minus. But then, notice 8 can be split up further. My perfect squares are 1, 4, 9, 16, 25, 36, and so forth. But my only one really that's smaller than 8 is 4. So I can split this into root 4 times root 2. So plus minus root 4, root 4 times root 2. And then the square root of 4 is 2. So my answers here are going to be x is equal to a negative 2 root 2 and a positive 2 root 2. And then I need to classify if it's rational or irrational. So notice that has a square root, square root, square root, square root. They all have square roots, so those are all going to be irrational. And then you want to double check, do you have 4 of them? I have 1, 2, 3, 4 zeros, so I do. So I'm just going to say, for my final answer, negative root 2, positive root 2, negative 2 root 2, and a positive 2 root 2. And those are all irrational. For my final answer. Okay? Alright, go ahead and pause the video, and you guys can try this example on your own. Okay, hopefully you had enough time to practice this one. Here's the solution. You can go ahead and pause the video and copy it down if you need to. Alright, so for our next example, we're going to be looking at binomials. So in this case, I have g of x is x cubed minus 5x. So for binomials, in order to factor, you want to first check for the GCF, and then you want to check for dots. And so in this case, I can see that they both have an x, so I can factor out an x by dividing each of those by x. So my x goes out front. And then x cubed divided by x is going to give me x squared minus 5x divided by x would just leave me with 5. Make that equal to 0. And just like we did on the previous example, we need to make each piece equal to 0. So I'm going to take this x, make that equal to 0. And then to solve for x, that's already x by itself, so I don't have to do anything there. And then I'm going to do the same thing with the x squared minus 5. Make this x squared minus 5 equals 0. And then we're going to add 5 to each side. And I get x squared equals 5. Take the square root, do a plus and a minus, and then check can 5 be broken up? My only perfect square that's smaller than 5 is 4. So 4 does not go into 5, so I can't do anything. So that's going to stay as negative root 5 and positive root 5. And then check the degree. Tells you should have a total of 3 zeros. So I have 1, 2, 3. So I got all of my zeros. Now I have to figure out if they're rational or irrational. So 0 does not have a square root, so 0 would be considered rational. And then I have the negative square root of 5 and the positive square root of 5. Because those have the square roots, those are called irrational. Okay. All right. Next example. Notice I got x squared minus 10. I don't have a GCF and I don't have dots. So you just go straight to making this equal to 0. I have the x squared minus 10 equals 0. I'm going to just add 10 to each side, and I get x squared is equal to positive 10. Take the square root of each side, and I got a plus and a minus. Then check, can you simplify? My perfect squares are 1, 4, 9, 16, 25, and so forth, but those are the only ones smaller than 10. 9 doesn't go into 10, 4 doesn't go into 10, and 1 does, but you'll just get 1 times 10, so that's not going to be very helpful. So I cannot simplify. Those are going to stay as just root 10. So I'm going to have x is negative root 10 and positive root 10. And then double check, do you have all your zeros? I have to have 2 zeros because that's squared, and I do. I have 1 and 2. So for my final answer, I'm going to say negative root 10 and positive root 10 are both irrational because of the square roots. Okay? All right, I'm going to skip this one. Let's go ahead and go over this one. We have f of x is x cubed plus 9x squared. I need to see if I have a GCF. So in this case, I do have a GCF. My GCF is an x squared. So if I factor out my x squared, I'm left with x plus 9 equals 0. And then if I try to solve for 0 here, I have this x squared, but this x squared, I'm going to do this on the side. You don't have to copy this down. But if I have an x squared equals 0, and I take the square root of an x squared, that'll give me like x is equal to like negative root 0 and a positive root 0, which that can be anything, but the square root of 0 is going to be 0. Like 0 times 0 is 0, but 0 times 1 is also 0, but it's not the same number. So the ones that are the same are 0 and 0. So I'm going to have like a negative 0 and a positive 0, but 0 is not negative, 0 is neutral, it's not positive or negative. So really I only have 2 zeros really. But I think that's kind of confusing if we do it this way. So instead of doing it that way, let's just think of x squared as being the same as x times x. And then I still have this x plus 9 up front, in the back, and that's going to equal 0. And so then remember, we're taking each piece and making it equal to 0. So this x, make it equal to 0. And it's already x by itself, so that's one of my zeros. And then for the next one, I have this x. So I have x equals 0. Solve for x, but again, that's already solved. So then go to the next one. I have this x plus 9. And I'm going to make that equal to 0. And subtract 9 to each side. That will give me x is equal to negative 9. And then double check your answer. Again, you're supposed to have 3 zeros because of the cubed. All right, so again, that cubed means I have 3 zeros, which I do. I have 1, 2, and 3 zeros. But if you notice, I have 2 zeros, and that means when we are going to eventually graph it. So you have to recognize that that means there's multiplicity. So for my answer, I'm actually going to say that that's 0 with multiplicity times 2, because I have 2 of them. And then I also have negative 9. And all 3 of those are rational because I don't have any square roots. Okay. All right, so in our next example here, we have 2x cubed minus 24x. If I check for my GCF, I'm going to divide by 2x to each of those. They both have a 2 and an x in common. So my GCF of 2x out front, 2 divided by 2 is 1, and x cubed divided by x is going to leave me with x squared minus 24 divided by 2 is 12. and x divided by x goes away. Now I'm going to make that equal to 0. So then again, you want to make this piece equal to 0. I have 2x equals 0, so divide by 2. That gives me x equals 0. And then for the next part, I have x squared minus 12 equals 0. So add 12, and I get x squared equals positive 12. Take the square root of each side. I need a plus and a minus. So x is equal to, I need to simplify, root 4 times root 3 with my plus and minus. So that brings me then to my final answer is going to be x is equal to a negative 2 root 3 and a positive 2 root 3. And then all I need to do is to classify. So I have 1, 0, and there's no square root, so that's called a rational. And then I have a negative 2 root 3 and a positive 2 root 3. Both of those have square roots, so those are called irrational. All right, and you can go ahead and pause the video and try this one. Okay, hopefully you paused it, and here's the solution. So this one had a GCF of 4x. That leaves you with x plus 3. This one solves it kind of weird here where it does the 4 not equal 0 and x not equal to 0. 4 not equal to 0, that doesn't make any sense, so that doesn't give you a 0, but then make the x equal 0. Or you can do it as 4x equals 0, divide by 4, and that'll still give you x equals 0. And then for the next part, you make the x plus 3 equals 0, subtract 3, that gives you negative 3, and 0 and negative 3 are both rational. So that is the end of the lesson. We'll work on the assignment in class. So thank you for watching. Have a good rest of your day.